Hello everyone. Right now I want to present my final project in biometric class. This is emotion recognition with ECG, GSR, PPG, and EMG signals using Vision Multimodal. First, I want to introduce myself. My name is Widya Angelina. You can call me Angelina. I'm from Sejong University, as a master student. So starting with the background. Biometrics can be used for UI UX research. Nowadays, UI UX research only using manual research to be able to gathering data for users to get how the device will working properly in every users. So instead of using the manual system, we can using a manual system that have like subjective results. We can use the biometrics to detect emotion to get more specific and details objective result. Emotion recognition using biometric sensors can be indeed available tool in UI UX research. By monitoring biometric signals, we can gain insights into users' emotional states and response during interaction with user interface. So, biometric sensors provide objective data about users' emotional experience, which can complement the self-reported feedback. The second one is a helpful device for children with autism. As we know that autism children not being able to express their emotional states as our normal beings. So indeed, we need something devices to be able to understanding what they're feeling at that time. So this is the biometrics recognitions can be a helpful devices for the children with autism. Emotion recognition using biometric sensors can be indeed beneficial in the context of autisms. Individual autism often experience difficulties in understanding and expressing emotions, which can impact their social interaction and communication skills. So this is really helpful for them. So let's starting with the introduction. The problem is so this is the problem statement. Emotion recognition is essential for understanding human behavior by combining multiple physiological signals like ECG, GSR, PPG, and EMG. We can create a whole system of fusion multimodals that can provide more accurate and comprehensive assessments of the emotional states. So all of these sensors contains the physiological signals that can be useful for the feature extraction. As such example for sensors, the ECG sensors measure the heart rate variability, whether GSR is like captures change in skin conductance. PPG records the blood volume change, and the EMG measures the muscle activity. So by leveraging all the sensors collectively in emotional recognition system, we can obtain more comprehensive and accurate understanding of various emotional states. So I will explain all the sensors in a brief. The first one is GSR and PPG. GSR is a type of biosensor that measures a change of electroconductance across our skin, which reflects the activity of sweat glands and the autonomic nervous system. So basically, it measures the change of the electrical around this area. So the PPG photo plethysmography is a measures blood filament change in our body. This is the examples calculating the formula for resistance and conductance. We'll be using the conductance and also the resistance for another purpose. So this is I'm using Simmer for all the sensors. This is the examples of recording the data using consistent software that from the Simmer company. So the FEC if you see, in the first one is GSR signals, which is the conductance level. Oh, sorry, the resistance level, and the second one is the PPG signals. So this is how I used the simmer, which you can find in their manual instruction of simmer. This is the GSR, and we'll be using the PPG right here to measure the blood volume change. So based on the measuring the user experience third edition by Bill Albert, so they're conducting the UI UX research, and they find that the level of stress increase along with the increases of heart rates and the skin conductance. So it can be simplified that it can be assumed that increases in skin conductance means increases of the level of the stress. So based on this, we can calculate the emotion recognition. The second one is ECG. ECG is type of biosensors that used to measure the electrical activity of the heart. So this is the RA. RA is right arm, LA is left arm, RL is right leg, and LL is left leg. And this is the V1, V2, V, and until the V6. So in this experiment, I'm using just the LA-RA model. This is when I'm conducting the experiments to record the data from the ECG. We can see I only record the LARA, and this is the result after I processing using the MATLAB. You can convert from these signals to CSV, and after that you can plotting all along the time into this kind of graph with the MATLAB actually. So interpreting how we interpret the ECG. So ECG signal itself using this kind of what is called, it was the pinpoint of each signal. So there is PQRST. So basically the PQRS is the depolarization and the ST is the repolarization. So by using this characteristic, using this characteristics of shape, duration, and time of RR, we can calculate the emotional states of the human. And the last one is EMG. EMG is electromyograph that measures the electrical activity of the muscles, corresponding nerves that control them. So our muscle actually produce the contraction and relaxation, and it states its difference between the contraction and relaxation. This is the example to conducting the experiments. It's the same. So this is the states of the relaxed condition signals of the EMG, and this is the states of the contraction one. So after we map, we can see that this is the relaxation state of EMG, and when it was like our muscle is contracting, this is this signals, and we can see the rapid frequency right here, and after that it was relaxation again. So there's two methods that I will be using this experiment. The first one is characteristic-based method. I will be using the ECG, EMG, GSR, and PPG characteristic to measures the emotional states of a human. And the second one is classifier trying method. So I get the feature extraction and I give it into the classifier to be able to decide what's the emotional state of the human. So this is the emotional valence arousal mapping. So this map is, you will find it in all the crossed paper of the biometrics, especially in the emotion recognition. So I will be choose four class, which is like happy, relaxed, or normal, and the third one is sad, and the last one is stressed. I'll be using this to divide to conducting all across the experiment. So let's move the first one based on characteristic methods. I plotted all the characteristic of the sensors and mapping it into this table. As you can see, this is the characteristic of ECG in the happy, sad, stress, and neutral. And this is the characteristic of the EMG. And this is the characteristic of the GSR and PPG. So after collecting this one, I move it to the decision phase. After like conducting many experiments to see how it's actually based on characteristic can define the emotional states of human. After that, I moved to the decision phase. So, for example, this is the ECG analysis. We are recording the ECG signals and export into CSV. And from that, I extract all the features of the ECG signal. For this step, I get only the HRV from the ECG signals. So HRV signals have like several parameters. This is and this one I'm using the STNN. So if the STNN more than 0.13, so where did I get this number? I get this number from conducting all the experiments. So I use this threshold because it's defined, it was like decreased ARV or increased ARV. More better using this threshold. So after that, if it was decreased ARV, so I'm thinking about how it's defined. It was like stress or sad. So I check all the features. So I get, if the rhythm is abnormal, it was the emotional states of stress. If the rhythm is normal, it was like sad. This case also happen in decided between the normal and the happy states. So if it was the heartbeat is more than 70 beat per minute, the human at the time was the happy states. And it was if it was below the 70 BPM, the human state is normal, the emotional. So what is the STNN? STNN itself is the standard deviation of the NN intervals and one of the HRV in this of our parameters from the ECG signals. So STNN itself is different across the age of and the sex of the people. And we move on to decision phase of GSR and PPG. So in GSR and PPG, we conducted the sensor fusion. So we fuse the GSR and PPG and get the emotional state decision in the end. The first one is we classify the skin conductance. We see the trend. If the trend is decrease, the human state is between the normal and happy. If the trend of skin conductance is increased, the human itself has the stress or sad level. So after that, we either like check the trend of the pulse amplitude to define the normal and happy. and also detect the pulse rate to define it was stress and sad. After that, we move to a decision phase of EMG. So we got the EMG signals and we classify the muscle's response. So by classifying the muscle response, if it was mix of inclusive response, the person at the time is currently in the stress mood. If the trend of muscle's response is quick, the person is the happy state. So if the response trends of the muscle at the time is slower, it was normal or sad. So we must check another parameters to decide it was normal or sad. So I come with instantaneous frequency. If it was higher than 2.3, it was sad, and if below the 2.3, it was normal. So after that, I fuse all the decision into one final decision. I'm using the weighted sum fusion. So I'm calculated and weighted in the such example GSR and PPG. I set the weighted is like higher than the EMG, and ECG also higher than EMG. So I conducted all the experiments based on that. So I get the final decision. And this is the development phase. This is the example of ECG. Actually, you can see on my GitHub this codes later. So the second one is classifier training method. So I'm using the classifier training using MATLAB at this time. So the first one is I gathering the data. All the data is my own data and data sets. I'm using the pre-processing to denoising because the sensors signals have noise. And after that, I'm taking data and I extract the feature, and after that I classify the data and I got the model, and I do classification inference, and I got the result of each sensors. So I'm using the ensemble method, and also I'm using the Adabus M2 to get more higher performance. And this is the final decisions of the sensors. So I get the GSR and PPG, and I got the ECG also, and get the EMG. I collected the final decision, same with characteristic based method. I'm using the weighted sum fusion. So the result of this is how I'm using the GSR, and this is the PPG, and this one is EMG. I'm using my arm. So we can see this is when I gathering the data. So simultaneously I gathering all the data of sensors. It calls multimodal. So after I record all, I processing the data, and this is the first one is characteristic based method. So we got the final decision at point 2 point something, and I decide that it was set. And if you're using the training learning classification, also get this emotion asset, so it's the same. So this is the second experiment on the normal states. So I got the normal emotion final decision, and also in the training one, I got the normal emotion. So from this mapping that you have seen before, I was thinking, what if we're using arousal valence mapping to decide the final decision instead of using the weighted sum fusion? So I made this one by 0 and 1. We can see how get the 1 So it was happy, it was pleasant, more pleasant in the valence, and more high in the arousal. So at this quadrant I got the 1. So I was happy is one pleasant and one arousal. It's the same with all the emotion states. So I added into the code decision on the final results, final decision. So this is the examples of using weighted average, and this is using arousal funds mapping. I think using the arousal funds mapping is actually more accurate because it's already proof instead of the weighted one. We must like conducting many experiments. So it's better using the arousal funds mapping. So this is how this is the first one is characteristic based diffusion one example of using the code. So it's just like running it because I already complied all the code in the one running code. So this is the training one. So I get all the models. You can see this in the map. And you can find my code in, this is the source code already published in the GitHub using the MATLAB. And this is the references. So that's all. And also figuring out there are many types of EMG. Actually we, because it was like emotion recognition, we can more rely on the face muscles instead of our leg or arm muscles. So it's more accurate if you're using the facial muscle instead of the leg and arm. So you can use the product of the EMG that calculate the muscles of your face. It's more accurate for emotion recognition. So that's all. Thank you for watching.